unfold.
Okay, let's unpack this. We're going to start this deep dive with a sound. And it's not the sound of a bomb or an alarm or, a crashing server. It's the terrifying sound of physics going sideways. I want you to just close your eyes for a second and listen to this industrial whine of mass and speed. It's late 2009. We are deep underground at the Natanz fuel enrichment plant in Iran.
And that sound you're hearing? That's the noise of thousands of silver tube centrifuges spinning uranium hexafluoride gas at just colossal speeds.
We're talking over 1,000 revolutions per second.
That's supersonic velocity. I mean, you are right at the knife edge of what that aluminum alloy can physically withstand. At those speeds, everything is supercritical.
So what happens if something goes wrong?
Well, if the temperature fluctuates, if the rotor wobbles even slightly, the aluminum tube yields, it expands, and then it shatters. The technicians, they have a really grim word for this. They call it a crash.
And as the winter of 2009 turned into 2010, these crashes, they stopped being, isolated mechanical failures. They became a relentless epidemic that just defied all explanation.
But here's the central mystery. This is the chilling core of the whole story. While the physical world was literally tearing itself apart, while engineers could actually hear the metallic scream of rotors dying through thick concrete walls.
The control room monitors, the digital systems, they showed complete calm.
That's right. The SCADA systems, the supervisory control and data acquisition interfaces, which are essentially the digital brains of the facility, they were displaying this comforting, uniform sea of green indicators.
So the readouts insisted that the speeds were steady.
Perfectly steady, at their nominal frequency of 1,064 hertz. The vibration sensors showed smooth textbook operation. The system was screaming, everything is fine, while the reality was just chaos.
The engineers must have been completely baffled. They assumed it had to be a physical problem, right?
Of course. They replaced batches of aluminum, thinking they had bad materials. They checked the power grid for surges. They checked the ventilation. They were looking for a physical cause for a physical problem that was demonstrably happening right in front of them.
But they couldn't find one.
They couldn't conceive that the root cause wasn't physical stress, but logic corruption. A ghost had slipped into the machine. A digital entity had hijacked the neural pathways of their Siemens S7 315 controllers.
So it was blinding them.
Blinding them with a looped recording of absolute normality, while under that deceptive mask, it was methodically and frankly, sadistically destroying the highly sensitive hardware.
Today, we are diving deep into that ghost. Stuxnet. This deep dive is built from, a whole range of sources. Technical analyses, the exhaustive investigative reporting that followed, and the historical accounts that confirm Stuxnet as the world's first true cyberkinetic weapon.
And our mission today is to trace this digital bullet. From the moment it was conceived in some highly secure, classified government program, through its impossible journey across the air gap to its precise technical execution deep inside that Iranian nuclear facility.
We need to understand how a piece of software achieved physical destruction, fundamentally changing warfare and proving that the line between the digital and the physical, it's been permanently erased.
Exactly. This malware wasn't about stealing data. It was about causing hardware failure and manufacturing sabotage without dropping a single bomb.
So to really understand Stuxnet's existence, you have to understand the target, Natanz, and why it represented a problem that conventional military power just couldn't solve.
Well, the problem really boils down to sovereignty and escalation. For Iran, developing its nuclear capability after the 1979 revolution and that brutal Iran-Iraq war, it was viewed as the ultimate guarantor of national independence and security.
And Natanz was the centerpiece of that ambition.
The irreplaceable centerpiece. And the political tension just escalated dramatically after dissident groups revealed its existence in 2002. That led to successive rounds of crippling UN sanctions.
And globally, especially for the U.S. and Israel, a nuclear-armed Iran was seen as an unacceptable existential threat. The clock was ticking.
It was. But the location of the facility provided the ultimate defense against a conventional attack.
Because it wasn't just some factory.
Absolutely not. Our sources describe it as a fortress built to withstand attack. It's located about 160 miles south of Tehran, and these centrifuge halls are massive, built to house up to 50,000 centrifuges.
And crucially, they're buried deep underground.
Deep. Buried beneath 20 feet of reinforced concrete and covered in tons of earth. They're also protected by anti-aircraft defenses designed to repel fighter jets.
So the strategic challenge becomes pretty immediate, doesn't it? If you can't hit the target with conventional means, you have to redefine what a weapon is.
Immensely so. The U.S. and Israel understood that any conventional military option, an airstrike, would require specialized bunker buster munitions that might not even guarantee full destruction.
And even if they did, the risks were enormous.
Huge. You risk triggering an environmental disaster by breaching containment, causing significant collateral damage, or worst of all, igniting a devastating regional war that would just dwarf any immediate threat.
The goal became destruction without escalation.
Exactly. They needed a non-kinetic solution that yielded kinetic results.
If you can't bomb the building, you have to bomb the parts inside. And the most vulnerable part was the machine itself. So let's zoom in on that IR-1 centrifuge. Why was this specific machine so susceptible to digital manipulation?
Well, the IR-1 is, technically speaking, pretty primitive compared to modern designs. It's based on the stolen Pakistani P-1 design, but it's effective.
And its function relies entirely on pure physics, right?
Pure physics. You inject uranium hexafluoride UF6 into the tube, and you spin it incredibly fast. Centrifugal force separates the heavier, unwanted U-238 from the lighter, fissionable U-235.
But the separation is tiny for one machine.
So tiny. So they have to be linked in these long, optimized chains called cascades to get the enrichment level they need.
The key to the entire operation, then, and the key to the attack, is that rotational speed.
Precisely. The nominal operating frequency for the IR-1 is 1,064 hertz. Now that translates to 63,840 revolutions per minute. RPM.
Which is just staggeringly fast.
It is. So to attack this machine, you don't need a bomb. You need an intimate knowledge of the physical limits of that specific aluminum alloy tube.
So let's walk through those two crucial physical limits, because these are the choke points that the Stuxnet attackers weaponize.
Okay, the first limit is resonance. Every rotating machine, whether it's a tire on your car or a high-speed centrifuge, has natural frequencies where it vibrates most violently. If the rotation speed matches that natural frequency, the vibration is amplified exponentially. It's the danger zone.
It's sort of like pushing a swing, right? You hit it at just the right time, and the oscillation just gets bigger and bigger.
Exactly. So engineers program the speed controllers to blast through these critical resonance frequencies instantly during startup and shutdown. But if the controller allows the speed to linger, even for a moment, in that danger zone, the wobble amplifies until the rotor strikes the casing.
And that's the catastrophic crash.
That's the crash. And the second limit is the actual material strength, the tensile strength, the point where the material physically gives way.
So there's a speed at which it just breaks.
Yes. That aluminum alloy rotor has a maximum yield strength. If the speed goes significantly higher than that 1,064 hertz threshold, the centrifugal force overcomes the metal strength. The tube begins to expand, a phenomenon they call ballooning.
And then it shatters.
Microfractures form, and the whole thing just shatters. The genius of the attackers was realizing that both of these physical limits, resonance and maximum speed, were entirely controlled by digital devices.
The digital gateway, the frequency converters, or VFDs.
Yes, these variable frequency drives are the motor's throttle. They take the standard power grid frequency and convert it to the precise high-frequency current needed to spin the centrifuges at 63,840 RPM. And those VFDs were controlled by Siemens S7315 programmable logic controllers, PLCs.
And PLCs are everywhere. They control assembly lines, water pumps, HVAC systems.
And in this case, nuclear material enrichment. This is the crucial point for you to understand. The attackers realized they didn't need to breach the concrete. They needed to hack the logic gate of the PLC.
But how did this piece of malware get inside a facility that was supposed to be protected by the ultimate defense, the air gap?
Well, for years, security professionals treated the air gap as the gold standard. A network physically disconnected from the public internet. No Ethernet, no Wi-Fi, no Bluetooth.
The conventional wisdom was you needed a spy, a human mole, to physically plant a device.
Exactly. But the Stuxnet creators knew the air gap was a philosophical boundary, not a physical one.
You're saying it was a placebo, not a perfect shield?
It functions more like a membrane, not a wall. Information has to cross that gap for legitimate reasons. System updates, diagnostic logs, new software installs, and how does it cross?
Removable media, USB flash drives, laptops.
So the air gap defense, which cost millions, was defeated by a $10 thumb drive.
Unbelievable.
Essentially. Our sources, particularly the investigative reports detailing the operation, are clear on this. The NATO's engineers themselves were the bridge. They would work on computers in the administrative offices or at home, connecting to the public internet, and then they'd carry infected USB drives right into the secure zone and plug them into the SCADA terminals to move files.
So the weapon was just waiting for a ride.
It was specifically engineered to ride this simple human-generated bridge. It was waiting for the perfect ride.
Okay, so the story of Stuxnet going from this classified U.S.-Israeli military program to a public security crisis. It's a fantastic piece of investigative history.
Yeah.
And it starts nowhere near a military headquarters or an intelligence agency.
No, it starts in a small office in Minsk, Belarus. Minsk. The detective story begins in June 2010. Sergei Ulesin, the head of this small antivirus firm called Virus Blockada, takes a frantic call from an Iranian reseller. The reseller is reporting really erratic behavior. Computers crashing, stuck in endless reboot loops, and displaying the dreaded blue screen of death.
I can just imagine Ulesin at a small firm in Minsk being completely dismissive at first. I mean, it sounds like a generic, run-of-the-mill IT disaster. Pirated Windows, bad drivers, that kind of thing.
That was his exact reaction. He assumed it was a mundane troubleshooting issue. He told them the standard procedure, reinstall Windows, clean the system. But when the problem persisted, even after multiple fresh installations, he realized something keeper was happening.
So he asked for a sample.
He requested crash dumps and the system sample causing the issue. And what landed on his desk was this tiny, innocuous-looking file named WTR4132.tmp.
And this tiny file contained the first layer of truly mind-bending sophistication, the 𝐏𝐿𝐃 day. This is the point where that air-gap defense just completely collapses.
It is. Ulesin and his colleague, 𝐏𝐿𝐃𝐂𝐀𝐒𝐓, discovered that the malware didn't need the user to click and run an executable, which is the standard mechanism for USB viruses. It didn't even rely on the old autorun.nf trick.
So how did it execute?
The malware executed automatically merely because the user opened Windows Explorer to view the contents of the USB drive. They just had to browse the directory.
That is the ultimate passive attack. The computer was just trying to render an icon for a malformed shortcut file, a LNK file, and that action triggered the malicious payload.
That's the 𝐏𝐿𝐃 day, later categorized as CVE 2010-2568. Stuxnet placed a specially crafted, corrupted shortcut file on the USB drive. When the Windows shell tried to process that file to display a thumbnail or an icon, the person code had a vulnerability. And this vulnerability allowed the malware to execute its main payload silently, without prompting the user, without confirmation, without them running a single thing.
Let's pause on the significance of the zero-day itself. We hear the term all the time, but why is finding one deployed in the wild such an alarming event?
It's the definition of a security nightmare. A zero-day signifies a vulnerability that is unknown to the vendor, in this case Microsoft. This means there are literally 0 days of protection against it. There's no patch, no antivirus signature, no fix.
These are the crown jewels of the cyber black market.
Absolutely. They're often valued by brokers and intelligence agencies for hundreds of thousands of dollars each. Finding one actively deployed signaled that whatever entity created Stuxnet was operating with virtually unlimited resources and a mission far beyond financial gain.
But the digital espionage didn't stop at the silent entry. The malware needed to completely disguise its identity once it was inside the system. It needed a passport of trust.
Indeed. To operate effectively within the Windows operating system, particularly to load deep-level system drivers that interact with hardware software, has to be digitally signed. That digital signature is the passport. It tells Windows, this software is verified. It comes from a legitimate trusted vendor. Let it bypass the security checks.
And the Stuxnet driver. It had one of these.
It bore a valid digital signature from Realtek's semiconductor core.
Realtek is a massive, recognizable name in the hardware world, so the attackers didn't use some sketchy fake certificate. They used a legitimate one.
Which means they had compromised Realtek itself.
That's the chilling implication, isn't it? To get that valid signature, the attackers had to steal Realtek's private cryptographic key. That key is typically the most protected digital asset a corporation owns, usually stored in a physically secured facility or a dedicated hardware security module.
This suggested the attackers were capable of physical theft, or a high-level network compromise of a major global corporation. Not to steal blueprints or money, but purely to create a digital disguise for a completely unrelated attack thousands of miles away.
That fact alone just screams nation-state capabilities, not typical hackers.
No question. And the military-grade planning only continued. On July 12, 2010, Virus Blockada notified Microsoft. Days later, the world learned about the worm, which was quickly dubbed Stuxnet. But the attackers were already one step ahead.
So once Stuxnet was public, the world's cybersecurity heavyweights Symantec, Kaspersky, IBM, they began this massive undertaking of digital forensics. The team at Symantec, led by people like 𝐏𝐿𝐼 and 𝐏𝐻𝐃, started performing the digital autopsy. And what they found wasn't just malware. It was a military doctrine written in code.
That's a perfect description. They realized this wasn't just a worm designed to spread. It was a payload designed for extreme precision. Most malware is small, maybe 10 to 50 kilobytes, often sloppily coded, optimized for data theft or financial gain.
Stuxnet was different.
Stuxnet was a massive 500 kilobyte leviathan. It was built with a complex modular software architecture, written carefully in multiple languages, C, C++, Mass, and assembly, suggesting a massive, well-organized development team.
I remember that famous quote that dissecting it was like seeing a fighter jet in a museum of paper airplanes. That analogy really emphasizes the difference in resources and intent.
It does. It required a level of engineering discipline and complexity that was previously unseen in the malware world. But the most staggering revelation wasn't the size. It was the sheer arsenal of highly valuable exploits they were willing to just discard.
Deep inside the code, they found evidence of 4 separate zero-day vulnerabilities.
4. In one piece of malware.
Let's spend time on this arsenal. Burning 1 0-day is a luxury. Burning 4 in a single campaign is essentially signaling unlimited resources and the highest possible stakes. What were the 4 roles?
Okay, so the first, as we covered, was the 𝐿&K shortcut exploit. That was the breach, allowing it to jump the air gap from the USB drive without any user interaction. That was just the door opening.
Right. But once it's inside one computer, that computer might just be a workstation. It needs to spread across the internal local area network, the LAN, to find the specific machine running the Siemens control software.
To move laterally, they needed a separate exploit.
Why couldn't the 𝐿&K exploit just handle that?
The 𝐿&K exploit was for initial execution. Once inside, they needed a persistent, robust way to jump between hosts on a closed network. And that was the print spooler exploit.
The print spooler.
Yes. This bug allowed the worm to spread by impersonating a printer job, which is a highly trusted function in corporate networks. It moved silently from one computer to the next, mapping the internal topology of the Natanz facility.
That's already 2 0-days gone. But even if the machine it lands on is the correct engineering workstation, the malware still needs system privileges, total administrative control, to access and rewrite the deep-level files that control the PLCs.
Exactly. Even a local admin account wasn't enough to perform the required low-level actions, so they deployed 2 separate, highly valuable privilege escalation exploits.
2 of them.
2. One targeted the Win32k.sys kernel driver, and the other targeted the task scheduler.
So they had backups for their backups.
Precisely. They used 2 separate methods to gain system privileges, or God mode, on the infected machine. This guaranteed that regardless of the minor version of Windows, or if one patch happened to be installed, the malware would achieve total control. The strategy was scorched earth. Guarantee the mission success, regardless of the cost of the tools.
Burning 4 separate, high-value cyber assets on a single campaign. It just speaks volumes about the unlimited budget and the mission's singular importance. This wasn't about recouping costs.
No, this was about political outcome.
And the military-grade planning extended to anticipating their own discovery. The operational tempo was phenomenal.
It truly was. When security analysts, likely spurred by Microsoft, tracked the source of the stolen Realtek certificate, VeriSign was notified, and they revoked that certificate on July 16, 2010. Any software signed with it was now instantly untrusted.
The attackers must have known this revocation was coming.
They absolutely anticipated it.
Very good.
Because the very next day, July 17th, a new version of Stuxnet appeared in the wild already. And it was signed with a new, valid digital certificate from J-Micron Technology Corp., another prominent Taiwanese chipmaker, located in the same science park as Realtek.
So they had a reserve key.
They had raided a second corporate fortress, secured a reserve key, and deployed the updated payload within 24 hours of the first discovery. That level of readiness confirms high-level, military-scale logistics and planning.
Despite all this incredible firepower, though, Stuxnet infected over 100,000 computers globally across 155 countries. But outside of Iran, it caused 0 damage. It just sat there, dormant.
And this highlights the concept of digital precision, the hunter-killer logic.
Great.
This is key to understanding its design philosophy. Stuxnet was a digital sniper, not a shotgun blast. It contained a highly specific, complex fingerprinting routine. Upon initial infection, it didn't immediately try to attack. It queried the system, looking for one specific thing.
Siemens Somatic Step 7 on WinCC, the software used by industrial engineers to program and manage the PLCs.
Exactly. If it didn't find that specific software, Stuxnet stayed dormant. It simply waited for transport via another USB drive to a machine that had the specific tools used by the Nathan's engineers.
So it filtered through a global crowd of thousands of infected machines, looking for that one target workstation that bridged the gap to the critical infrastructure.
It was never about general disruption. It was purely about physical sabotage at one specific location.
Okay, so Stuxnet has successfully navigated the air gap, used its arsenal of 0 days to achieve God mode on the engineering workstation, and confirmed that the machine is running Siemens Step 7. Now, it needs to commit the crime without the chief engineer knowing.
This is where the PLC rootkit comes into play. And it's arguably the most technically brilliant part of the entire operation.
Right.
Stuxnet needed to manipulate the physical hardware while simultaneously feeding the human operators a stream of lies. To do this, it had to insert itself directly into the communication pathway between the software and the controller.
And that software, the Siemens Step 7, communicates with the physical PLC hardware using a specific library file, a DLL, called 7outbxdx.dll.
That's the key. Stuxnet hijacked this crucial system file. It renamed the original, hid it away in the system, and then inserted its own malicious, custom-written version in the original file's location.
If I were to use an analogy for the listener, this is like replacing the official trusted security guard with an imposter.
That's a perfect analogy. This established a classic man-in-the-middle attack, not on a network connection, but on the engineering process itself.
So let's break down the result of that hijacking. When the Nathan's engineer used Step 7 to read the code running on the physical PLC to check if the controls were stable, what did the imposter DLL do?
Stuxnet intercepted that reading request. Instead of pulling the actual corrupted code that was actively destroying the centrifuges, Stuxnet displayed the clean, original safe code that the engineers expected to see.
Yeah, I was the master.
Exactly. The engineer was staring at the monitoring tool, convinced everything was correct, but the tool was actively lying to them under the control of the malware.
And conversely, when the engineer tried to upload new code, say, a patch to fix the crashes or a diagnostic tool, what happened?
When they uploaded legitimate code, Stuxnet secretly injected its own malicious blocks of code alongside the clean code. The engineers were completely compromised. They trusted their own viewing tools and their own uploading process, both of which were being manipulated by the ghost in the machine.
But the precision goes even deeper than that. Stuxnet was ridiculously selective. It didn't attack any S7315 controllers that happened to be running.
No, it attacked one specific, unique configuration. The code performed a second, granular layer of hardware fingerprinting. It queried the precise system configuration, looking for specific Profibus network modules and checking for the vendor IDs of the frequency converters, specifically Faro-Päivävirran and Vacon of Finland.
And according to Ralph Langer's deep analysis, the code looked for a configuration of 31 frequency converters.
31. Think about that level of insider knowledge. That configuration was not generic. It did not exist in a typical power plant, or a water treatment facility, or a card assembly line using Siemens PLCs.
So where did it exist?
That specific setup existed only in the pilot cascades of the Natanz fuel enrichment plant. This confirmed that the creators of Stuxnet had intimate, actionable insider knowledge of the physical layout and design specifications of a highly classified facility. Knowledge that could only have come from a state intelligence operation.
Let's get to the physical payload itself. The frequency attack targeting those S7315 controllers. This wasn't a random crash. It was a slow, methodical application of targeted physics to induce material fatigue and failure over time.
It truly was a masterpiece of mechanical sabotage implemented digitally. Stuxnet executed a specific three-part attack cycle, played out over a nearly month-long period, designed to systematically break the aluminum tubes.
Okay, so step 1, establish normality.
The baseline. Stuxnet would sit silently for days, confirming that the centrifuges were operating at the stable, nominal 1064 Hz frequency. It established the system was running normally before the sabotage began.
And then, the first act of violence, the overspeed.
The overspeed. The malware commanded the frequency converters to ramp the speed up dramatically to 1,410 Hz, which is 84,600 RPM. This phase lasted for 15 minutes.
And the physics here is just unforgiving.
It is. Centrifugal force increases exponentially with the square of the speed. At 84,600 RPM, the aluminum rotor is subjected to immense tensile stress.
This causes the expansion, the ballooning, and microfractures begin to form inside the metal structure, weakening the whole thing.
Exactly. It might not burst immediately, but you've inflicted permanent structural damage. It's the digital equivalent of striking a piece of metal repeatedly with a small hammer, inducing fatigue.
So 15 minutes of extreme stress, and then the actual kill shot was the third phase.
The crash. Stop. After the overspeed, Stuxnet commanded a rapid deceleration, dropping the speed almost to a complete stop down to 2 Hz for a staggering 50 minutes.
That's the truly diabolical step.
It is, because as the rotor slows down from extreme speeds towards zero, it must pass through its critical resonance frequencies.
Which normally the control software would just blast past so the machine doesn't have time to vibrate catastrophically.
But Stuxnet forces the rotor to linger precisely in the danger zones or pass through them so violently that the wobble becomes uncontrollable, causing the rotor to strike the casing and shatter. The crash is guaranteed. Then, the system returns to 1064 Hz and waits 27 days before repeating the cycle.
That 27-day gap, that's the key to the psychological warfare aspect, isn't it? If they had all exploded at once, Iran would have instantly known they were under a coordinated attack.
Exactly. But breaking them randomly over weeks and months made it look like quality control failure, bad materials, or operator error.
It systematically eroded the confidence of the engineers.
It did. They wasted months troubleshooting physical problems that weren't physical, trying to fix a production issue instead of realizing they were under attack. This slow kill strategy maximized confusion and minimized the chance of the Iranians realizing the true nature of the threat.
And that wasn't the only payload. The attackers had a secondary and arguably more dangerous attack plan targeting the higher-end S7-417 controllers.
Yes, the system that managed the gas flow, the cascade protection system. This was the valve attack.
Okay, so the frequency attack was mechanical sabotage, stressing the metal, but the valve attack sounds far more catastrophic. What was the goal here?
The code targeted the complex interlinked logic of the 164 centrifuge cascade layout, which is standard at 8 ends. And the malware was designed to manipulate the valves controlling the flow of the UF6 gas itself.
How?
The code could close the valves on the product and waste lines while keeping the feed valves open.
So you're pumping gas into a system with nowhere for the gas to go.
Precisely. The pressure builds up rapidly.
That could lead to a catastrophic explosion.
Absolutely. The overpressure could simply blow the centrifuge apart. Or the UF6 gas, which turns solid at room temperature and pressure, might solidify inside the rotor, leading to immediate failure and massive contamination.
So the valve attack represented a more acute danger.
It was designed for faster, more violent physical destruction than the slower frequency cycling. The fact that the attackers developed 2 completely distinct, highly sophisticated, and lethal payloads suggests a layered approach to guarantee the facility's shutdown.
And through all of this, the operators were completely blind. Let's talk about the 21-second blindfold, the ultimate deception.
Stuxnet implemented a classic replay attack. Before initiating the overspeed or the valve manipulation, the malware recorded 21 seconds of completely normal sensor data smooth speeds, normal temperatures, normal vibrations, from the input-output memory blocks.
And then during the attack?
During the attack sequence, Stuxnet disconnected the real sensor inputs from the monitoring system.
So it's playing the recording back to the control room?
It's the ultimate nightmare scenario for an engineer. On the screens, they saw green lights, smooth 63,840 RPM displays, and stable vibration readings. In reality, the rotors were screaming at 84,000 RPM, undergoing violent resonance and tearing themselves apart.
The instruments were lying, the safety systems were disabled, and the operators were literally flying blind into a catastrophic failure they could not see or stop.
Exactly.
So the moment security analysts finished their forensic dissection, the conclusion was inescapable. The sheer resources involved, the 4 days, the 2 stolen corporate certificates, the military-grade operational tempo, the intimate knowledge of Natanz's unique hardware, this could only have been the work of a state actor.
Absolutely. Criminal enterprises develop malware to make money or steal data. They don't invest hundreds of millions of dollars developing a weapon designed only to destroy industrial infrastructure. The signature was unequivocally that of a nation-state.
And in 2012, that conclusion was formally confirmed by David Sanger of the New York Times, revealing that the code was part of Operation Olympic Games, a highly classified joint intelligence effort.
This was a collaborative effort primarily between the U.S. intelligence community, the NSA and CIA, and the Israeli Unit 8200.
So a joint operation.
A joint operation. The U.S., having developed the bulk of the code, provided the technological sophistication and resources. Israel, with its proximity and urgent concerns regarding Iran, was crucial in providing the operational intelligence and likely the testing environment.
What was the ultimate strategic goal of this incredibly complex, multi-million-dollar operation?
The goal was overtly political and diplomatic. The attack, which ultimately destroyed roughly 1,000 centrifuges in two major waves, delayed Iran's enrichment program by an estimated 12 to 18 months.
And this delay was intended to achieve two things.
First, to buy time for diplomatic negotiations to take place. And second, and crucially, to dissuade Israel from launching a preemptive conventional airstrike. The U.S. feared a conventional strike would immediately trigger a catastrophic regional war. Stuxnet was the invisible, kinetic alternative.
But even with all the 0 days and all the state intelligence, they still faced that initial challenge, crossing the air gap. The code had to be carried in physically. And this brings us to the most recent and fascinating layer of this investigation, the Dutch connection.
The air gap required an insider, and recent investigative reporting, specifically from the Dutch newspaper De Volkskrant in 2024, provide the crucial missing piece of the puzzle, the hands that delivered the weapon.
The Dutch intelligence service, AIVD.
They were allegedly recruited by the CIA and Mossad to find and manage a suitable mole. And that mole was reportedly a man named Eric van Sabben.
Who was he?
Van Sabben was an ideal, almost custom-made candidate. He was a Dutch engineer with a technical background. He had significant business dealings in Iran. And critically, he was married to an Iranian woman, giving him a plausible, non-suspicious reason for his frequent travel and access.
So the theory is that van Sabben infiltrated the NATE-10's facility as early as 2007, possibly under the guise of installing or servicing equipment like water pumps or ventilation systems.
Yes. He either carried the contaminated USB drive, the patient zero, or, more sophisticatedly, embedded the malware directly into the specific hardware he was installing, allowing the Stuxnet code to take residence within the physical infrastructure.
That moment of physical connection facilitated by spycraft bridged the entire chasm of the air gap,
Making the digital attack possible.
and this high-stakes operation, blending cyber warfare and physical espionage, it had a dark ending for them all.
There is a chilling coda. Eric van Sabben died in a sudden motorcycle accident in Dubai, just 2 weeks after the successful deployment of the attack in 2009.
An accident.
Well, officially it was ruled an accident. But the timing is extremely suspicious and continues to fuel speculation about whether the operation's handlers considered him a liability that needed to be neutralized, or if it was simply one of history's cruel coincidences.
Beyond the sophisticated planning and the spycraft, the attackers couldn't resist leaving a definitive, almost arrogant signature hidden deep in the code string.
It's the ultimate calling card for a secret organization. Researchers found a specific embedded Project Hath string in the code. B. 𝐏𝐎𝐃𝐂𝐀𝐒𝐓386
The keyword there being Murtis.
Myrtus, which is the Latin name for the myrtle plant. In Hebrew, the word for myrtle is Hadassah. And Hadassah, of course, is the birth name of Queen Esther in the biblical book of Esther.
The Queen Esther, who was a Jewish woman in Persia, modern-day Iran, who saved her people from a plot to exterminate them.
This highly specific poetic reference served as a clear, veiled statement about the operation's authorship and motivation. It was a cultural and historical fingerprint left on a digital weapon.
Stuxnet was engineered for surgical precision. It was supposed to be a ghost that lived and died quietly inside that heavily guarded air gap. But in the summer of 2010, the operation failed in one critical, catastrophic way.
It escaped.
It escaped confinement.
This leak was a disaster for the intelligence agencies involved. The prevailing theory is that an Iranian engineer connected an infected laptop to the air-gapped network, got infected by the worm, and then took that laptop home, connecting it to the public internet.
And because Stuxnet contained an aggressive replication feature,
A feature designed to spread easily across the target LAN, it jumped the boundary and began spreading rapidly across the globe.
suddenly, the blueprint for cyber-physical warfare, a weapon worth hundreds of millions of dollars, was exposed to every security researcher, every state actor, and every hacker group in the world.
It was Pandora's box opened digitally. Stuxnet proved definitively that code could cause physical, kinetic destruction. It destroyed 1,000 centrifuges. But its legacy is defining the threat landscape we live in today. It completely erased the theoretical line separating the digital world from physical security.
Ralph Langner, the expert who helped crack the Stuxnet code, had a grim but entirely accurate warning about this moment.
He warned that the idea of a cyber weapon is now out of the bottle. Once the knowledge of how to weaponize PLCs and industrial control systems was exposed, it could not be recalled. And we have absolutely seen the sons of Stuxnet emerge in the years since, applying those lessons to new targets.
Let's detail those successors, because they show the evolution from attacking a highly specific nuclear program to attacking civilian infrastructure.
Well, we have two key examples of follow-on attacks built directly on the Stuxnet template. The first is Indestroyer, used in 2016 by Russian-backed actors.
And this malware was designed to target what?
Electrical substations. And it was successfully used to shut down a significant portion of the power grid in Kyiv, Ukraine. This was a direct attack on essential civilian infrastructure, causing widespread outages and disruption.
And the second, which is arguably even more terrifying because it targeted human life, is Triton.
Triton, discovered in 2017, targeted a Saudi petrochemical plant. This malware didn't just target the PLCs running the operation, it went after the safety instrumented systems, the SIS.
The critical digital safety locks designed to prevent catastrophic failures, explosions, and loss of life.
Triton was explicitly designed to override the SIS, suggesting the attackers intended not just to break machinery, but to cause massive, potentially fatal industrial explosions. It moved the goalposts from sabotage to potentially mass casualty operations.
If we summarize the incredible statistics behind Stuxnet, a compact 500 kilobyte file that contained 4 0 days took an estimated $100 million and 6 months of intense development time from 2 global powers, all to destroy about 1,000 centrifuges and delay a nuclear program. It was a technical triumph of engineering and espionage. This entire story, from the physics of the rotor ballooning to the biblical clue in the code, it's a complex detective story where the killer was a ghost in the machine. It didn't just redefine what a weapon could be, it redefined what vulnerability meant in the modern world.
If we connect this to the bigger picture, the legacy of Stuxnet is profound and enduring. The air gap is dead. We now know that every piece of industrial control machinery connected to a network, whether it's the power grid, a refinery, or water treatment plant, is fundamentally vulnerable to logic corruption.
The weaponization of logic.
The weaponization of logic, the idea that you can weaponize the very systems designed to keep things stable, is now a permanent reality in global conflicts. It is an enduring shift in the nature of warfare that we are still grappling with.
Which leaves us with one final provocative thought for you to consider. Stuxnet was an operation executed with unlimited budget, using resources built and deployed by 2 of the world's most powerful nation-states. It was a surgical tool designed to be perfectly contained within a secure facility, yet it escaped and exposed its blueprint to the entire world. If a highly targeted weapon like that could not be perfectly contained, what does that say about the security of any critical infrastructure connected to the physical world today?